Once again, good evening, all of you. Once again, welcome to the sessions. I request Dr. P. Suman Garu, co-coordinator of this FDP, to give brief introduction to the Dr. Sunil Kumar Sharma ji, followed by session.
Thank you, Dr. Santosh. My voice is audible?
Yeah.
Yeah. Good evening, everyone. We are privileged to welcome Dr. Sunil Kumar Sharma, a distinguished academician and researcher, as a key speaker for our FDP. Dr. Sharma currently serves as a chairperson of Rail Vehicle Technology at the Institute of Railway Vehicles and Railway Technology, Technical University, Dresden, Germany. Having done his master's from MNIT Allahabad, Dr. Sharma holds PhD in Rail Vehicle Dynamics from IIT Roorkee and complete his postdoctoral research at CN University, South Korea. Before joining TU Dresden, he worked as a faculty at Gatishakti Vishwavidyalaya, Vadodara and Amit University, Delhi, where he contributed significantly to teaching and research in all rail vehicle dynamics and related fields. A prolific researcher, Dr. Sharma has authored 93 Scopus publications, included 34 SCI indexed journal papers as listed on Scopus. His research focuses on vehicle dynamics, contact mechanics, mechatronics, real-time systems, and software-enabled control system for high-speed rail vehicles. Notably, from 2021 to 24, Dr. Sharma has consistently been recognized among top 2% scientists worldwide in prestigious global list accompanied by Stanford University, USA, a testament to his exponential contribution to rail vehicle technology. We eagerly look forward to learn from Dr. Sharma, vast academic and research experts, as he share his insights on digital twins for railway system during this program. I request Dr. Sunil Kumar Sharma to deliver a lecture.
Thank you, Dr. P. Suman, for the kind introduction and telling about me to the audience. I would like to share my screen. Please let me know whether it is entirely visible.
Yeah.
I hope the screen is visible.
Yes.
Yeah, it's visible, sir.
Okay. Thank you for confirmation. Just a sec. Okay. Yeah. Is it clear now?
Yes. Perfect.
Okay. Thank you. So thank you once again for inviting me for this session to give in a talk on digital twin in railway system. As I've already thanked the AICTC and the ADITYA Institute of Management and Technology for giving me this opportunity to present my work on digital twins in railway system. So currently I'm holding a position of Chair of Rail Vehicle Technology at Technical University, Dresden, Germany. So this work or the presentation for this session, I would like to cover about the introduction and the core concept of digital twin. And I will also discuss about various applications where we can use the digital twins and how the digital twins are effective and how we can introduce it to the system. Then I will talk about its benefits in the rail systems and also what are the challenges and technological factors. I will also cover one of the case study in which I would like to describe how we will do modeling and how we will take out the responses of the system. And then I will conclude by conclusion and the future trends of the work. So before we start about the digital twins and all, we would like to understand about the glimpse of what is rail vehicle dynamics and railway system is thing. So when we talk about rail vehicle dynamics, as you can see, for the transportation, or you can say the sustainable transportation, the railways are the backbones, and yet they are facing lot of challenges in terms of efficiency, safety, and innovations. But the digital twins are there to promise a transformative leap, or you can say the transformative changes by providing a dynamic data-driven lenses to view and optimize railways operations. So when we talk about rail vehicle dynamics, we need to understand what exactly the components we are covering in the vehicle dynamics part of the railway, and what are the components are there in the railway systems. So when we talk about rail vehicle dynamics, we will have to look out what are the components.
Hello.
Sunil, probably you have muted. Please unmute, sir.
Yes. You are not audible. Please
Okay.
check once. Yes.
Okay, fine. Now I'm audible.
Yes. Please go
Okay.
on.
Okay. So since where I have means got the muted starting.
No. It's okay. Just now.
Okay. Fine. So when we talk about this rail vehicle dynamics, we are talking about what are the components, the major things are involved. So I have just covered about what is the rail wheel interaction is all about, which is basically look after the contact dynamics about the rail and wheel and how it can dedicate it to enhance the safety and all the train to travel safely. This also includes about wear, rolling resistance, and all other things are come into the picture when we talk about the rail wheel interaction. So the other aspect of rail vehicle dynamics when we talk about is the suspension systems. So basically suspension system are the system which absorbs all the vibrations coming into the system from the various interactions happening like rail wheel interaction or track dynamics, irregularities on the track. So the suspension system will counter, or you can say reduce, the vibrations coming from the track to the bogies and bogies to the car body. Then there is an aerodynamics which plays the major important role when we talk about the energy efficiency and the stability of the system, which is especially very important when we talk about the high-speed rail vehicle, which is everywhere now the research focus is going on. If we have the poor design, we will lag into the lot of problems related to drag, increasing energy consumptions, and end of the day, it will cost, or you can say it will make a system inefficient. So we need to focus more to understand how we can reduce the drags and all. Now coming to the railway systems. So the railway system basically includes, you can say, the other aspect of the tracks like tracks, signaling system, power supplies, and the stations. And digital twins can enhance them by largely by looking for the various aspects like tracks and signaling system. When we talk about tracks and signaling system, these are basically the foundations where signaling system can ensure by controlling train movement. So digital twins allow real-time monitoring of the track conditions and also automate the signaling for increasing reliability. The other aspect of railway system is the power supply. When we talk about the power supply, it's a, you can say it's a virtue of which, or you can say the power supply is a source of rail vehicle which it runs, and digital twin can help us to optimize it also. Then there are the stations and the passenger flow. We will need to count when is the rush hour, when is the normal hours, how we can distribute the train timings in such a way that it can help us to design a system so that there will be no bottlenecks in the system. Now, once the glimpse of rail vehicle and railway systems being understood, we have to see how this system is very complex. So just by seeing and by understanding the basic idea of the dynamics of railway train is, we need to design, or we need to make a system in such a way, or you can say make a system of railway system in such a way that it should carry people and goods with more safely, comfortably, and economically. But by doing by understanding this objective, these are not the easy objectives to counter it. We need to understand about various dynamics, what is dynamics happening. So, and there are a lot of components are also involved in this dynamic. So whenever we talk about rail vehicle, or we see the trains in India also, there are locomotives, there are coaches, and then there are the different suspension systems depending upon different, like locomotive have a little different suspensions for parameters compared to the coaches. Then there is a lot of interactions were happening. The major interaction is the rail wheel interaction where all the major vibrations comes. Then there is another interaction happening at the face of the locomotive where the aerodynamics plays the role. Then there is an interaction happening between the coaches and the locomotive where the coupler dynamics come into the picture, and etc. There are a lot of different kinds of complex system and engineering are taking places together. But what are the challenges? The major challenges is these are very complex systems. And to do the modeling and to understand how we can implement the digital twin to the system, we must understand that how the systems are integrating with each other and how the impact of the track irregularity and vibrations are coming on the stability aspect of the rail vehicle, which is very essential to understand how we can do the modeling and to do the analysis for the rail vehicle system. Now, having said that about the rail vehicle system, we must understand how we can introduce the digital twins to it. But before going towards the digital twins in the applications of rail vehicle, which I will discuss in detail, we must understand that the introduction, how we can introduce the digital twins to the system. So first we must understand what is digital twin. So we know many times we have seen there is a twin system is there. People usually follow, or sometimes we will have twin skid which look like alike to each other, which are very similar, having same properties, same look very similar to each other. Same concepts comes here when we talk about digital twin. Digital twin is nothing, is just a digital, you can say, a virtual representation of the physical asset. The meaning of virtual representation here is the replica is not static. Try to understand the point. It's not like that we are just making it and we will keep it like that. No, it is not static. It is continuously updating its behavior, or you can say it's continuously updated with the real-time data capturing from the physical counterparts. Makes it dynamics and accurate. So why we are doing this? Because it should behave as a physical object, does under the different scenario, provide insights, also predictions that would be impossible to do it. For an example, I'll just show you a simple case. This is a modern jet engine, as you can see in the image, which is the physical system. Now, with the digitalization, we are making the exact thing in a digital system, which you can say we can model using different softwares, depending upon what type of things he wants to do. And this system continuously modified by the real-time input from that system. And then we can predict, or you can say, understand the performance of the system by virtue of doing different, to giving the different scenarios to the system and try to replicate the model out of it. Then, why it is matter, why everything is matters, why we are talking about digital twin, why we are unnecessary putting a lot of brain to it. The reason behind is the digital twins allow us to test, monitor, and predict the behavior of the complex system virtually before making the physical changes. This is very important to find out that we are not doing any changes in the physical system, but we are doing everything in a digital system to understand the behavior and the pattern of that particular physical system, how it will behave. Suppose this thing going to be happened, or suppose there is a failure can occur, then how much time we will have to maintain it, or how much time we will have to do the you will say the change of the component if it is required to be changed. So in railway system, as you can see, it's very complex. As I have already told you, it's not very easy to understand because a lot of things are add on to here. So because of this complex system with the rolling stock, track, signaling system, and the station, all interactions are happening in the real time. So there are a lot of components for doing the interactions at every seconds, and lot of data is getting generated, and then the things has to be do. So digital twins enable us to simulate and analyze those components and dynamically and unlock the new efficiency. So here you can see the system which has been developed by the Deutsche Bahn and the Stadler. Deutsche Bahn is the German railway manufacturer, and Stadler is also one of the major AI, you can say computer-based industries, which helping us to develop this AI digital twin system, which we are showing here. So as you can see, we were having a train, you can see the physical train. The exact train has been modeled in a virtual world, and all the data are going to the virtual train, and we can able to find out. Let's see, in this case, suppose the actual train are standing and the virtual train is showing that at the bogie part, which is the red box you can see, is having some kind of a disturbance, or you can say by doing the more analysis, there is a case of failure. So to do the experiments every time on the, you can say, physical system, it's better we can track the system virtually and able to find out and do the required thing by adding all those things. So this is basically the glimpse what exactly happens when we model a train to a digital twin platform. Now, how the digital twins come into existence, what is past, why we need to move to digital twins, and what exactly it is. So I just give you the glimpse what exactly happens here is. So digital twins basically evolving from, you can say, over a decade now, and they begin with the conceptual scientific model and have now transformed into the sophisticated tool powered by the real-time data and the advanced simulations. So to understand the journey of coming towards the digital twin or digitalization, mainly towards the creating the twin part of it. So as you can see, in 1985, when the things were start, when model pioneers during that phase, the scientific expert relied on physical, basically they relied on the physical and the mathematical model to understand the phenomena and conduct the kind of failure analysis. But so they do finite element analysis to do engineering and predict and take out the stresses and all the analysis being conducted. But in near about 2000, the change is that we have the scientists have integrated the computer-aided tools to do the little bit of turning there, turning point of the system, where with the help of CAD, they can visualize what is happening and try to figure it out how we can resolve the thing. Then in 2015, as you can see, the PLM prevision came into the picture, which is basically nothing but the product life cycle management system became very important, where they are doing the analysis, like how much is the product lifetime and how we can manage, how we can increase the lifetime of any product. So there they usually do the collaborations across the departments, and model-based system engineering come into a picture where the streamlining of the project will get, you can say, development process will take place. Then the era of digital twins comes to the picture, where the digital twins brings together data and executable model accessing for all the stakeholders. So here in this, what is exactly happening is all the, you can say, the stakeholders like called business drivers or the generative designers can come together and try to find out what best can be done for the system. So if I give you this example, like the Siemens uses digital twins. Siemens, which is a very big company, uses digital twin in the manufacturing plant to monitor and optimize production process in real time. That's why their production process is very good, and they are having very lag time in terms of the production. So how you can say things are evolved in terms of modeling, as you can say, they are the physical models and they are the volume of relevant data comes to the picture is. So basically data driven, or you can say when we talk about digital twin, data driven models basically uses machine learning to predict based on the last database. And the simulation models, when we talk about the simulation models, and they basically create the proxy of a real world scenario and try to get the output of it. And the knowledge base which we are talking here is basically the early models. where the rule-based and reliant on the manual interpretations happens. But digital twins will integrate the simulation as well as the machine learning aspect so that we can get into the much better idea about the system. So how we can build a digital twin? This is one of the important thing to understand here. How we can do it. So the first idea is to understand what are the physical assets, what we were having, and how we can do it. It's on a digital mode and do various type of analysis. So basically, what is the physical models? If I talk about simple physical models are, you can say, are simple models with a smaller database. Means you have made a something based on the manufacturing output. You will design a system and system is there in place. Then what is happening to the system? You need to go, you need to test, you need to identify, but you do not have the advantage of understanding before it's happening to the system. But what happened when we talk about the system, when it is in a digital mode? So basically in digital mode, we make the replica out of it and create basically virtual replica of a physical asset by creating, or you can say by collecting the sensor data. So what is happening here is how we are making the digital twins model, or how we are building is we are taking the data from the sensors and try to build the physical system and do with the help of digital modeling, we can do the simulate the behavior of the physical asset under the different operational scenarios. So what could be the features we can capture if we talk about converting this aspect from here by getting the data from the sensors is we can continuously update our model so that if suppose you have made a model right now and if some new data come into the picture, then you can enhance your model by incorporating those things. Second, you can simulate the performance of the optimized operations. Means you can optimize further as it is real time getting updated. So for an example, from day 1, you have designed something. On day 10, because of some failure, or you can say not failure, but because of unexpected data or unexpected behavior of a system, you can redefine the optimization on the day 10, and then you can see the product life cycle and other aspect of the system and how you can modify it. Then in the third mode is the failure mode. Of course, end of the day, why we are doing all these things? Because we want to know when the system gets failed so that we can save it before failing it. Or we can reduce the maintenance time by knowing it. Okay, now this is a time when the system can get failed and we need to change the system. So you can prepare by bringing all the components that is required and you are knowing about the failure time so that your failure period where the maintenance takes, suppose for an object for 2 days or 3 days or 5 days, you can reduce to hours so that your manufacturing time will not get reduced and your continuous manufacturing can be happen there. Then the other aspect is the insight framework, where what is happening is the actions, you can say divided into few categories. What is actions, what is insight in the data. So basically in the actions part, we can do the fleet optimization. We can do the performance management. Moreover, in insight, we can compare what you have designed, built, as maintained, as operated scenarios. So we can have a multiple scenarios there. We can do the prognosis and the future performance forecasting of doing the system. Moreover, with the data, we can alert and warn the system, and we can diagnose the issue if it is coming way early, then it should be there, means, or we should know after things. Then what are the aspect, how we can build? So once we understand about the basics of building it, now I'll take you to the journey, or you can say the steps which are involved in the digital twins or building of the digital twin system. So to build a digital twin system, we will have the process of, let's say, 6 steps. And each steps were helping us to gather, understand how we can make a system, how we can do the visualizations, what could be happen, and those things like that. So first and foremost step on the building of digital twin is to get the data. So to get the data is the first step, which basically collects the raw data from the physical rail vehicle. For an example, if I'm taking the example of railway system, from the physical rail vehicle and its environment, So the sensor and Internet of Things device are installed on the critical component to continuously monitor and do the conditioning. For an example, in the rail system, we usually have wheel sensors, track sensors, and environmental sensors. And there are other sensors also, which depending upon our requirement. Like for an example, collecting the data on speed, braking forces, engine performance, like that. So the second steps coming into the picture is processing data. How we can process the data. We will have a lot of raw data, but how would you process it? So for processing point of view, we need to understand data is in the form of very noisy and unstructured way. And the process of pre-processing, basically what do in the processing data is, it will clean, organize, and convert this data into, you can say, format which is suitable for analysis. Because we will generate random of data. A lot of things are coming to the data, and we don't know what data is important, what data is not important. So we need to do the pre-processing of the data so that we can eliminate the unwanted data and we can use the what is data is required to us. Then the point come here, the applying knowledge, which are the fundamental things here. So till now we have just got the raw data and the filtered data. So here comes the user domain expert. Basically, with the domain expertise and historical data, engineer may apply knowledge to interpret the processing data, which includes the building of, you can say, foundational models that describe the rail vehicle's dynamics and the behavior. So here, if you talk about the rail vehicle, we use historical data to identify the patterns where the wheel are degrading with time. Let's say if the wheel are new, and after, let's say, 1 lakh kilometer wheel runs, then what changes happen to the wheel? Like that, we take the data from the wheel and try to identify what is happening to the wheel and what is the factors affecting to it. Then we will apply the principles of rail vehicle dynamics to understand the interaction happening at that point where the rail and wheel are getting rubbed, or you can say the material loss is happening, wear is taking place. And with the application of knowledge, we will try to simulate the ride quality or ride comfort or reduce the vibrations. A lot of things can happen once we know what exactly the problems is. Then the fourth part coming is the simulation, or you can say the simulate. So simulate is nothing but is to simulate the model, the data that we are getting with the virtual behavior of it. And this can be modeled by doing a lot of testing on the various conditions without doing the physical trial, because you cannot do experiment every time. It's very expensive and it's time taking, but with the helping of digital twin, no need to do experiment again and again. We can generate and we can understand what is happening to the system. And then it comes about the visualization is like simulation result and real-time data are presented, through the dashboards, or you can say some of the example I'll show you here and how we can interpret the data that can help us to understand what is happening. And then in the end, after completing and understanding the entire system, we can able to find out what is happening at the casualty level, or what would be the root cause analysis of the system, which can be affect the basically relationships in the system where the interactions are happening with the different part of the system, and they are getting fail and they are getting unwanted forces, which can cause the failure of the system. So this is happening. So what helps us in terms of casualty in the rail vehicle side is we can identify whether overheating in the train engine is due to track condition, weather, or mechanical inefficiencies. Moreover, we can also analyze what are the recurring derailment in the specific sections and find out the causes to the poor track alignment. And the third thing is we can provide the maintenance team with a clear recommendation that such wheel needs to be replaced. Otherwise, there will be a dragging, or you can say the wheel are not rolling. The flat wheel condition will come into the picture. So we need to avoid those situations. Now, after having understand how we can build it, what is the significance in the digital twins for the railway industry? Fine, we understood about the rail system, we understood about the digital twins, we understood about how we can build the or you can say do the step-by-step procedure, but there should be a significance, right? Otherwise, why should we do it? So to understand the significance, the basic significance is that the Digital twin continuously monitor the real-time data from the train tracks and the environmental scenario to predict potential risk before it can get accelerated. So it enhances the safety of the system. That's the first important significance of digital twins. The second thing is optimizing efficiencies. So the optimizing efficiency means here the train operations, you can say by simulating, we can adjust the schedules, routes, speeds of the peak performance. So by understanding this, what we are doing is we are optimizing the system. The third and major thing here is also the improved maintenance. So see, what happening these days are in the urban areas, a lot of people are from the remote areas coming to the major cities and the urban cities. Because of this, the rail manufacturers, or you can say the rail, you can say operators, need to operate their train regularly, and they are not getting time for the maintenance. So what they can do is they cannot stop running trains. Otherwise, it will cost them and it will affect them their overall efficiency or economical aspect of the train operations. So they need to improve the maintenance. They are getting very less time for their maintenance. So that they should know when to maintain, when to bring the train inside the yard, when to do all type of analysis like wear, tread pattern, scheduling the repairs proactively, so that they can minimize the downtime and they can run their train, or their train should be on the track all the time, running and commuting to places like that. Then the last point, which is significant, is the innovation. With the innovation, what can be done is that a virtual environment for testing new designs, technologies, operation strategies without disrupting the actual performance. We can design a new system and can do the virtual kind of a thing to it, so that we can design new trains. Then we can do a lot of experiments. You can say, or we can create an environment where we can do the innovation in terms of track layout, signaling system, making informed decision before the physical deployment can be done. So these are the few things which are very significant when we talk about the significance of the systems. Now, we have understood about the significance, but what are the components involved in the digital twins? Physical, we understood. Building, we understood. What exactly the systems involved here is, if you can see the system which involves here is, first is data acquisition. Data acquisition system is one of the system. What it will do, when the sensor collect the data in a real time on the track performance, data acquisition system try to convert data into one form, physical form. You can say sensors are converting basically one form to another form, and data acquisition system will make the system with logics we can apply to it in a usable form, which can help us to understand the data. Then we need to generate a lot of simulation models to understand the train behavior with respect to different types of conditions. Then there is a real-time monitoring assets can be happening, where we are doing the real time of analysis and try to understand the systems. Then there is a control system which we can help to control or enable the adjustment happening in the train operation in real-time data. So how we use the data acquisition in IoT sensors? The main thing that I have discussed earlier, just about the wear wheel sensors, where this sensor will tell us about the wear and the tear happened on the wheels, and we can do the preventive maintenance for it. Then track conditioning sensor, which can give us the detail about the track geometry, identify the potential defects in the tracks, and also ensure the safe train operations. Then there is a thing is called environmental sensor, which tells us how the weather condition, track temperature, and other environmental factors are impacting on the train performance. Then the simulation models analysis. So we will develop simulation models and try to do the analysis, try to give the inputs to it, and see the system. So what happens in the simulation model? We need to understand what type of model we are making and what is the output from that model is coming. So for an example, suppose we want to do the vehicle dynamics model. What we do in that, we will do this. We will simulate the train behavior under different scenarios, like including braking, acceleration, and cornering. And the second model we try to build is the track interaction model, where we will see how rail and wheel are getting interacted and how wear, frictions, and noise generations were happening. Then the other aspect is the aerodynamic model, where we do the aerodynamics analysis of the system and try to see the behavior of the system with response to different angle of attack by the wind. It's not straight always. It can be inclined, it can be at some angle, it can be crosswind, it can be, in the air, there are dust particles are there are water particles are there. So we need to design an aerodynamics in such a way to understand how the system behaves in all those things. And then we need to do analytics, try to analyze the data and do the optimization for the proper operations and the track maintenance. Then this thing, which we are calling about real-time monitoring, also can be done, like train scheduling. I have talked to you many just now. Then we can get the real-time data, like sensors are continuously working to give us the real-time picture. Then we can deduct if there anything is having what deviation from the normal operating condition. So we can give, or you can say, alerting the alarm to the operator for the potential issues, and we can adapt. So there is a change in the situation. We can adapt from the change in that situation and try to resolve the things that coming in front of us. So now I will discuss one of the case study that we have tried to make the simulation model of a real case study and try to see if we can give the different inputs and how the systems are behaving. So I'll try to show one of the case study that we have done. So the case study that we are discussing here basically focusing on two things. First, we need to see how we can do the predictive maintenance. So idea behind here is to understand how the real-time system behaves, and then how we can proactively maintain the system. So how we are doing this? This is more about how maintaining, but the main idea here is how we can build, or you can say, develop a simulation model to understand the behavior of the system and try to incorporate the different things if we want to incorporate and see the behavior in the simulation, or you can say the real-time behavior of the data. So the case study is basically on the you can say the rail vehicle dynamics using semi-active suspension system. So the idea here is what happened that we got an objective that we need to design a rail vehicle in such a way that what will happen when the speed got increased, like we want to run a vehicle at 200 to 250 kilometers per hour, and that can cause a vibration and reduce the ride quality and ride comfort of the system, and as well as the stability of the thing. So what we have got here is the existing suspension system, which are insufficient at the high speed scenario, because this is a real case scenario, and we want to see if we want to increase the speed of the vehicle, how the vehicle will respond, and how we can develop a mathematical and the simulation model for this, and how we can correlate with the numerical simulations and the experimental data to tell that the model is accurate. And then we can try to develop the semi-active system to it and try to see the behavior is getting improved, and are we able to reduce the vibrations, or other kind of a thing can we do in the train or the coaches that we are selecting. So moving ahead with this case study, the objective that I have discussed you earlier is just for you, we just try to summarize that how we are proceeding ahead with the system here is. So first what we did is we did the modeling of the rail vehicle, which is the LHP coaches, which I have shown you, which you have seen in India as well in the Rajdhani and Shatabdis and other places. And then what we did is we did the validation of it at the maximum speed they claimed at 160 kilometers per hour. Then once the model is validated, we have tried to give the different type of scenario to it to understand how system will behave, or what will happen if we try to introduce the, you can say, the system to it and try to get the system out of it, the output out of it. So we have given the different types of, you can say, the input to it, different speed to it. And then we have incorporated the MR damper, because of course we do not have the real train running at 250 kilometers per hour in India. So we need to create a virtual environment for it to understand whether the system will behave at higher speed or not. So we need to incorporate or need to change the passive system to the semi-active suspension system, try to understand how the behavior can take place. So in the objective B, as you can see here, we have developed the scenario where we are incorporating the magnetological damper to the system and try to incorporate different types of currents to system and controllers also, so that the MR damper should behave efficiently. Then we have taken out the response for the passive system as well as the incorporation of the MR damper system, and try to do the analysis for right quality, right comforts, and try to improve, is anything is getting improved and are we getting any improvement out of it or not. So these are the basically the tasks that we were having to develop the model in terms of digital and to analyze the system and to do the analysis. So I'm not going into the extreme depth of the work, but I will show you the glimpse of modeling. So first we have done the modeling. This is first we have started with doing the mathematical modeling of the system, so that we can understand how different components are playing and how the system behaves with each other, because there are some constraints and there are system which is designed that way. So the first task is to understand and try to develop the equation of motion for the rail vehicle for the passive system, which is the existing system. We are not changing anything. We are not incorporating any new thing. Then once we develop the passive system, we are replacing damper. Let's say the first thing that we want to improve is the ride quality and ride comfort for the passengers. For that, we need to incorporate MR damper into the secondary suspension system of the rail vehicle, because secondary suspension system is between the bogie and the car body, and it will plays the major role in terms of reducing the vibrations and improving the comfort. So the task is to incorporate the MR damper into secondary suspension system. So after the incorporating the system, the model shows like this. There's a train vehicle model. We are giving the track input to it and try to getting out the data from the sensor, which is acceleration, velocity, and the displacement of the car body. And then we are giving it to the controller. What controller doing here is, it is doing its algorithm and tell us that how much force is required by a damper to reduce or damp out the vibration which are coming from the input of the track. So that the work is for MR damper, but there is a force tracking controller we have also give. It will track whether the MR damper is giving the right force to the vehicle or not. So we need to understand the system, whether it is giving the right input to the vehicle, so that we can analyze the system. Then the thing that we have done, we have validated that thing by using the experimental results by the field trial, and we have got the results, which you can see there is a gap, or you can say there is a little difference between the experimental results and the simulation results. Reason is, in the simulation, for the initial model, when we develop one first model, we will try to incorporate as much as we can, but few things will miss out during the modeling. So this will help us to enhance the system further, to identify what things we are missing, so that we can make a system which is exactly the virtual system of the existing system. So by doing this, we can reformulate the system, or we incorporate the components that we have ignored initially, and then we have remodeled it again. Then the other aspect that we are doing for the objective B, what we are showing is, we are incorporating the semi-active suspension system. So here we are simply incorporating the magnetological damper. The magnetological damper is a simple damper. What is happening in it? There is the iron fillings. When we apply a current to it, the magnetic field generated in the MR damper, and in the MR damper there is an iron fillings which will get aligned to each other. And because of that alignment, there is a viscosity flows, and because of that viscosity, we will get the damping effect that is needed or the required by the system to reduce the vibrations. So to doing this, we have tried to incorporate 3 different types of strategy to it. First, we have just given the direct current of 0.25 amperes. Then we have incorporated by including 1 ampere, and then we will vary the current based on the input coming from the track. And we did the simulations for different types of scenarios. So till now, what I have shown you is the mathematical modeling. Now we have done the same modeling using the VI rail model, and we have created the virtual, or you can say the model in the software simulation. So here we have the discussion that I'm doing for the bogie. It is a bogie with the suspension systems, with incorporation of all the data that are coming from the experimental. We have incorporated in it. So this is basically we have tried to create the exact replica of the real system. Then we have built the car body model of the coach, as you can see, and all the data is coming, the real data of the car body. For the designing part I'm talking about, we have incorporated here. Then we have built a system in such a way that the entire things are integrated in correct format, so that we can understand how the system will behave, and each and every part of the component will help us to get the results. Then once the simulation is done, we need to integrate the MR damper model as I am discussing. So we need to give some input to the system, or you can say try to get the system to the model. So we have to incorporate the mathematical model here for the MR damper. And we have done the co-simulation, or you can say the integration with the MATLAB, so that we can design a system in such a way that the integration can happen and we will get the output out of the MR dampers. Then the analysis took place, and we have done the analysis and try to find out how the system is vibrating. These are the self-vibrating, or you can not self-vibrating exactly. They are the modes on which the system is vibrating. So you can see the roll mode, yaw mode, bouncy mode, and the pitch mode, how we can get the output of the system and try to see the behavior, how the output is coming to the system. Then just by understanding, we are giving the sinusoidal input to the system just to see how the damper behaves. So here you can see in the damper, we have done the analysis at different speeds, because initially the task is to understand whether the existing vehicle will go to up to 250 and we can improve or we can reduce the vibration of the system or not. So here you can clearly see that we have done the analysis at the lower speed as well as the higher speed, and we have found out that yes, by just incorporating the system, we can get the better ride quality and ride comfort, which are now helping the manufacturer so that they can easily install the system and try to reduce the vibration. So this is in the acceleration pattern. You can see the acceleration, and there is a difference in the results in terms of passive, the three different types of strategies that we have incorporated in terms of semi-active, low, high, and control. Then the other thing here you can see in the displacement response of the system, where you can see the black line, or you can see the black signal is showing for the passive and green is showing for the semi-active control. And that's we can reduce, the amplitude is reducing, and we will get the output of the system. And you can see very clearly at 250, the output is much better compared to the passive system at 50 km/h compared to 250, because at higher speed, the semi-active suspension system performs much better compared to the lower speed. Then this is the thing that what I am discussing created in the virtual world. So I would like you to see the model, what we have created. And here you can see we are wearing the red color, as you can see in the rail, and you are seeing with the wearing this current because of vehicle is taking turn, how the forces are getting modeled. You can see the forces in the right side, and the modeling is taking place at the track forces coming into the picture, and we are developing in it. In the second scenario, you can see here in the comfort analysis, what we are doing is, you can see the vehicle is running, and then we are giving some disturbing to the system and try to see how the vehicle is responding. And in the third scenario, in the aerodynamics thing, you can see how we can do the virtual testing or giving the virtual different scenario to show how the things were happening, and we are calculating drag out of it. So these are the models that has been created, and we can see with the help of virtual thing, if the real system works or runs on the system, how we can get the output. And we can also give the real-time input to this thing, as you can see here in the first thing, in the second also, in the third also, we are continuously can change the input, as you can see, and we can get the output of it. Then, sorry. So After understanding the case study, the idea here is to understand where we can apply the digital twins, because digital twin can apply to any aspect of the system, or we can design the entire system. So the points where this digital twin can be applied to the rail vehicle dynamics is to rail wheel interaction, suspension systems, stability control. We can enhance the energy efficiency as well as the aerodynamics. So when we talk about rail wheel interactions, you can see the interaction between track wheel and the track dynamics. I have just shown you that it plays a major role in terms of the stability, noise level, and the wear and tear. So we need to optimize this to understand how we can reduce, or how can we optimize the friction, how can we predict the wear, and how we can do the rail wheel misalignment under the dynamic load. The second thing is to understand about the suspension system. The suspension system is simple, is basically absorbing the vibration and shock, as I have already told you, but it also ensures the passenger comfort, stability during the travel. So optimizing shock absorption for different type of track condition, we can understand that how we can simulate it with the different types of putting the loads, and try to do the test suspension design before physical implementation, which I have shown in the case study. The third thing, as you can see, wear and tear I've already discussed. The ride quality and ride comfort has already been discussed now. So about the energy efficiency and the aerodynamics part. So in the energy efficiency and aerodynamics, as you can see here, the energy efficiency basically focusing on the reducing the fuel or electrical consumption during the train operation. So by implementing the digital twin, we can save 5% of the energy saving by incorporating this system, 10% in aerodynamics design, and 20% reduction in the emission by clearly understanding and concept of aerodynamics. Because for an example, in the aerodynamics, if I take the case, aerodynamics determine how air resistance affect the train speed and fuel consumption. So if you see the aerodynamics formula, which is A plus B plus BV square, so you can see V is basically the speed. So at the higher speed, it's a factor of, you can say, V square. So it plays a major role in terms of, you know, to take the lot of fuel efficiency. So we need to design properly to get the best fuel efficiency in terms of aerodynamics. So that by doing this, we can enhance the aerodynamics, we can improve the energy efficiency and allow train to travel faster, while, this is important, right, while maintaining the safety and the comfort in the train also. It's not like that we are just increasing the speed and the comfort and everything is going out of the window. No, we need to maintain that stuff also. Then also the real-time operations and the management can be done, so that real-time data is coming. We can improving the efficiency and also doing the safety simulations and try to improve the safety measures of the system. And this we have already discussed about little bit of the reduce in the maintenance cost and the downtime. So you can see the proactiveness come into the picture, which exactly identify the potential issues that can occur. We can optimize the repair and also reduce the maintenance cost of the system. So by doing this, again, we can get the 10% reduction in the delays in terms of improving the scheduling and the real-time monitoring, and as well as 5% in the energy saving in terms of train operations and energy consumptions of the system. Now, what are the challenges? We have seen a good part of the digital twin. Digital can do wonders, but of course, it's not easy. It's having a lot of challenges, and a lot of technology enables we need to exactly showcase how the digital twin works in the railway system. So to understand about the first, I would like to discuss about the challenges. So here you can see the system. Here we are getting the data from the field. The data looks like this way. So you can see, if you are not aware of the knowledge, data is a mixing of lot of waves, lot of noise, lot of vibrations, lot of different types of effects are coming. So we need to understand it very clearly, what data is coming and how we can understand the data, which is useful to us. Sometimes if we're not able to understand about the data, definitely we model a wrong digital twin system for the thing. Sorry. So here you can understand that the data, or you can say the data integration is very important. So as I am saying, the railway system generating lot of massive volumes and data from the diverse sources, including rolling stock, track sensors, signaling systems, and the passenger flow. Integration is very important to understand the task of this thing. So this will help or to develop the collection of the data very properly. Then it is very high initial cost is required. It's not cheaper, as you can see. So it's very costly because a lot of things are coming to the picture. It's not something that we are getting the things very easily. So that we collecting the right data, as you can see here, I have listed the things is very required. Then the high cost of computing is there, but also nowadays there is very I can say few players are you can say having a good technical expertise, because the major challenges what we are facing is the people are not having you can say, or you can say they were having limited technical expertise in this area, because this is evolving field and people are getting information about it. The other you can say challenge, or you can see, I will show you the wheel of the aspect which what things are getting integrated with each different type of aspect. You can see with the physical data connection, with the physical service level, service data connection, model service data, then model data connection and physical model. These are about just the connections in the digital twin. So we need to connect all the ways in the connecting to understand the digital twin. The other major threat, as you can see in the challenges, is the cyber security risk, because the increase of reliance on the connecting system make railway more vulnerable to the cyber attacks, because cyber attack can come with a thing and they can, you know, control the system and create different types of things which are actually not happening. So this is the major challenge that we need to take. And the last and the important challenge, there are many other challenges, but the last challenge, which is the legacy infrastructure compatibility, because what is happening in many railway operates on a decade on old infrastructure, which may not easily integrated with the modern system. So we need to design, or we need to or sometimes you can set an example of outdated signal system, which may lack the ability of transferring the data to the real-time monitoring. So we need to design in such a way that the modernization and the development of the hybrid system can take place between the new and the old system.
Sunil sir.
Yeah.
Yeah. Sir, good evening. This is Dr. Kalecher.
Yes.
Sir. Sir, you these data you have taken for the total railway system, or only the tracking of the train during the movement, etc. you are using, sir?
The case study that I have discussed is about on the rail vehicle dynamics side.
Vehicle dynamics only.
Yes, because if I cover the entire thing, it will be a big aspect to cover. So to showcase the thing, I have taken the, you can say, the theme of rail vehicle dynamics mainly.
Okay, this. Okay, sir. Thank you, sir.
Yeah, thank you. Okay. Now, the technology enablers, or you can say what type of technologies are helping us to developing this digital twin. I quickly cover this. So as you can see, the technology that we required, which are existing and we have compiled together, is IoT, which basically having sensors, actuators, and you know, collecting data from different sources. And we are getting the data in the, you can say, the cloud computing and the data storage will helping us to take a lot of data which are coming from here and there. The other main technological enablers are the artificial intelligence and the machine learning, which are helping us to understand how there is a, you can say, problem, or how we can interpret the data collected by IoT, and we can identify different patterns and different types of irregularities, as you can say, from the normal systems. Then the collaboration and the technological partners are also important, who are giving us the softwares, hardwares, and they are bringing their expertise, so that there is a reduced implementation risk. Because end of the day, we need a system which is simple, which from where we can do different types of work, or we can see different type of analysis, so that we can end of the day understand the digital twin properly. Then The role of IoT and sensor data I have already discussed, but these are the applications where we can implement it, like track condition monitoring and also train performance monitoring and environmental monitoring aspect also. Even the artificial intelligence, machine learning are very important to do the predictive maintenance, optimizing the schedule, safety enhancement and other things. The high performance and edge computing, which we are talking about, is a real-time data integrating process, because this is a very important, real-time data is important. Then edge computing and you can say distributed computing is also required to do the different tasks that we need to do. Then the cloud infrastructure is also needed, because we need to have system at different places. We do not have system at one places. So all the data are coming into it can, be scalable, so that we need a cloud infrastructure. Security is also needed, and a lot of collaborations is required to do this type of thing. So end of the day, if we understand what exactly the overall role is, the overall role of digital twin is in decarbonizing rail transport is by 10% energy efficiency in terms of, you can say, overall reducing the carbon footprint. So initially, when I talk about the energy efficiency, was the aerodynamics. This time is for the carbon footprints, 20% in the renewable energy integrations, and the 30% of the sustainable infrastructure that we can build around this thing with the help of digital twin. So what could be the future? When we talk about the future of the system, future is good. And the trends are, we will having more AI driven system, which can help us to, enhance or upgrade the system to the better way. Then we can have a smart rail network, which are integrated with the smart city. And nowadays, the system is becoming so thing that we are trying to integrating with the two countries. So they can easily having the rail network where the integration can take place. Then we can have a sustainable transport, which can plays the very important role in terms of renewable energy and the energy efficiency. So summary and key away in a shortcut way, if I understand, if we implement digital twin to the system, we can enhance the efficiency, we can improve the accessibility and also the sustainability of the system. So just to conclude, what could be the vision, or you can say future call of the rail system and call of action should be, their future is basically bright. They can be powered by AI and digital twin, smart city integration, and so that we can build a sustainable, efficient, and accessible transport network for the generations, and enhance the system in such a way that we can optimize many things that needed to be optimized. So just by adoption of digital twin in the railway industry promises a future of a great efficiency, if I talk about, and the collaboration between the industry, technological providers, policymakers will be essential to unlock the full potential of this transformative technology. So thank you for you all attention. I'm happy to take questions, or if you like to discuss anything now, or maybe you can connect me via mail, collaborate with me if you want to be, if you are interested in this area of collaboration. Thank you.
Yeah, participants can raise their queries. I can see few raised hands. K.S. Gupta, sir.
Yes, good evening, all. Thank you, Sarma Saab, to giving a different aspect of something which we use but we never realize. And my little bit query is that with all this technological advancement and technological support, what are the behavioral aspect are challenging, or what are the challenges through the people behavioral aspect, people interfacing with the technology you came across, or you could highlight, or you could predict?
Yes. So the technology that we came across, like in the European cities, we will travel across a lot of countries which are, working at a different speed. Like for an example, from Germany to Italy, Germany to Paris, or if you want to travel from Germany to Prague. So what happening here is with this, the AI powered technology, I tell you that nowadays, even when we check the you can say how much train is late, how much train is on time, how the timetabling is scheduled, how we can know that the platform, the availability is there or not. So in these places, the technology has taken a big role, and they are helping the people for their better understanding of the system. Yes, initially it takes time for people to understand, but once they are understanding the system, it will really helpful for them for their optimized, you can say, travel from one place to another. So I feel that it is a good, you can say, a good, bright future for people in terms of people operating this technology.
Thank you. Thank you, Sharma sir.
Thank you.
Yeah, one more, Dr. G. Sachinarayana Reddy. Sir, please go ahead with your query. Dr. Sachinarayana Reddy. You have raised your hand, sir. Please go ahead with your query.
Are you able to hear me?
Yes, yes.
Yeah, let me go ahead. See, does the digital twinning addresses human error also?
Yes, sir, there will be. There is a human error always, but that's why it is not when we try to model that. In the case study, I have shown you that initially when we have modeled the mathematical model, we have not got the optimized result. So we have incorporated those mistakes, what the error was there, by understanding that we have not incorporated all the components which were there in the system. So later we have incorporated all the system and try to get as close as, or you can say, exact replica of the real system.
Okay. Okay, sir. Just I've got one more small question.
Yes,
the electromagnetic levitation trains.
yeah.
Why they are not able to replace these trains with the wheels? I mean, what are the major constraints, just to make a lay person to understand?
Actually, if you see the maglev train, which are running at the high speed, at the initial stage, they were having the rolling stock as well, because the magnetic circuit around it comes once the train pick up the speed at the higher speed. Even though why they are not replacing the existing thing is because it is very costly, or you can say very technological advanced system, and lot of safety is required there. So the problem with every you can say every country, that they need a entire new network, or you can say entire new infrastructure for it.
Okay.
So depending upon the use case of the countries, they are trying to develop it, but the point is bringing the technology from different countries, it's very challenging, and second, to design or to develop that bigger network which are dedicated to the maglev system is it's very challenging.
Okay. Thank you, sir. One last question, sir.
Yes, sir.
Only you can answer this question, actually.
Yeah.
Hydrogen trains are being actually manufactured in Germany for India.
Which one, sir?
According
Which
to
trains?
Modi. According to our Modi, Prime Minister of this country,
Yeah.
in the news, actually, they already ordered the hydrogen trains from Germany.
Yes.
They were expected in December 24, but they will be coming. So
Yes.
I suspect it operates on a solid fuel cells.
Yeah.
I don't think it's going to work on the hydrogen as a combustion fuel.
Yeah.
Can you throw some light on it? Actually, we have no idea about this new hydrogen trains.
See, hydrogen train, I cannot see. In Germany, hydrogen trains are failed. I tell
Okay.
you honestly.
Okay.
In Germany, hydrogen trains are failed, and they have closed this project to work there. There are several reasons to it, because to generating the infrastructure for the hydrogen train in Germany, they have done a lot of studies, but they came out, the thing is that it is not possible in the condition that what we have in Germany. So what happened? The current government has ordered that system to India, and Indian system is also trying. Actually, the announcement is very good, but right now to develop that, you can say the power system for the hydrogen train has not been, it isn't, you can say prototype happened, but to do the, long-term work for the normal routine, it's take time. So I have the cross fingers through it. Maybe it will work in India or not. It's a debatable thought.
Okay. Okay. Thank you, sir. Of course, in the news, what they said, the experimental basis, they are going to see the
Yes.
feasibility of these hydrogen trains. That's what's in the news actually.
Yes.
Thank
yes,
you very much, sir. Really, we are learned a lot.
Thank you so much.
Great amount of knowledge. Thank you very much.
Anyone else?
Sir, I have one query. Sir, am I audible?
Yes, please.
Yeah, thank you for sharing such a wonderful knowledge. Maybe my question may not be in line with your kind of work and all.
Okay.
See, recently we are hearing, past years, people have started working on underground, underwater trains.
Yes.
Right. So, have you ever experienced the modeling of such kind of train systems or vehicle systems, underwater technologies? Since if so,
Yeah.
what would be the main? See, if it is submarine kind of modeling and all, pressure is playing the key role.
Yes.
If so, what is the most important parameter or whatever it is? Yeah.
Okay. So, see, underground technology, or you can say the underground concept, is basically came with the idea of pipelines. You have seen in our cities were connected with the pipelines, and the pipelines are going sometimes under the ground, and sometimes, they are going by the closed structure of the oceans, or you can say the rivers and other things are coming to the picture.
Mm-hmm.
The same concept they are trying to implement. Of course, China has done a lot in this. And now we are also trying, like in Mumbai, Ahmedabad, you have seen they are trying to build the underground tunnel for it. So you can say the exact work I have not done on this particular aspect, but the idea and other things are coming from, like when they are doing, like you can say the Konkan Railway from the Mumbai. They used to do the drillings in the mountains and try to build a tunnel and try to do it. So
yes.
They are the people who are working in that particular aspect. They are looking about the ocean dynamics, wave dynamics, and the strength of the material of that pipeline, and what would be the life. Those things are taking the place. But as of me, I have not worked on that particular. You can say exactly how we do the modeling of it. So,
Yes, I understand, sir.
Yes.
One more. This is out of curiosity I'm asking.
Yeah.
Have you ever lively experienced? Have seen this underwater train system in Germany? At least I'm asking, since you are there, you are being there.
Yes.
Underwater.
In Germany, I have not seen underground, honestly, because
underwater, I'm asking.
Yes, sorry. Yeah, underwater, I've not seen in Germany because it's not there, I guess.
Yeah.
It's not there, but maybe soon, maybe I will experience it. But as of now, I not went to some construction place where this is happening. Underwater, I'm talking about under tunnel, underground, other things that I have seen.
Yeah, that is being going on.
Yes, but
across
water,
the world, it is going actually.
Yes, water is a nice area, needs to be explored.
Yeah, since my MTech scholar would like to go in that way, so that's why I'm asking it.
Yeah, definitely he can connect with me, and maybe you can connect. We can discuss more in detail about this.
Yeah, sure.
Yeah, sure.
Thank you.
Yeah,
that's it from my side.
One more, D. Asirinayudu garu. Yeah.
Yes, sir. Very good evening, sir.
Good evening. Please go ahead. Yeah, you are audible.
Yes, sir. Regarding human models, sir, is there any models in the MATLAB, sir, regarding your idea? Who is the traveling in the train? Okay, regarding dynamics of the human models.
Yeah, there are a lot of models for the humans. Like what type of analysis you want to do on the human
dynamics of the human body analysis?
Yeah, it's there. It's there. Means a lot of papers has already been published by how the force is being transmitted, how we can do, crash analysis if the human is sitting, lying, writing on the paper. Like there is a lot of pieces is already available, and I think more than lot of
Okay,
papers.
that real-time data is available, sir, for constructing the model.
See, real-time data for the human is available with the manufacturing. Like what they do is, suppose if you are sitting in the train, right?
Yes,
they will
sir.
apply sensor to your bodies.
Yes, sir.
And train is running, and they will capture the data what is coming to your body. Sometimes they will have a real body, or sometimes they will put a dummy body inside it. So we call it as dummy model analysis. And we do different type of analysis in the real-time scenario. Suppose if you are sitting, you suddenly fall down to the floor, what will happen to your body? So yes, we are doing that type of analysis.
Okay,
So,
sir. Thank you,
Thank
sir.
you.
Thank you very much.
Yeah.
Any other questions? Participants, any other questions, please? Yeah, I think maybe we can. Yeah, one more. Yeah, please, sir.
Yes, good evening, sir. Hello, sir. Am I able to, sir?
Yes.
You are ordered.
Sir, in the rail vehicle dynamics, how the speed of the vehicle, speed of the train in the modeling of rail vehicle dynamics, how the speed of the vehicle is coming to picture, sir, in the developing modeling, sir, equation of motions.
Yeah.
How the train speed is coming to picture, sir. Suppose the train is running at 80 kmph, 100 kmph, 250 kmph.
Yeah.
How the velocity term is coming to picture in developing equation of motions.
Okay. So developing the equation of motion, we need to understand how we are modeling the rail wheel interaction part. So whenever we are modeling the rail wheel interactions, there are different authors, or you can say scientists, have given their models. For an example, with the basic one is the calcar, then there is a non-calcar equations is there. Then there is an different types of other rail wheel interaction models are there. So in that, if you see those modeling, the V component is available there where the speed phenomena is coming into the picture. Moreover, with the track irregularity, we put it as an additional force, which is the you can say the input force from the system. But if you go through the non-linear calculus equation, the V component is there.
Okay, sir.
Yeah, so it is available. But mostly, if you want to do for the static speed, we are considering the constant speed, then you can put the same value. But if you are doing the analysis where your speed is getting increased, decreasing, or suppose you are applying brake or whatever you are doing, then you need to drive you can say force, or you can say the force velocity term to add in the rail vehicle modeling.
Oh, sir.
So yes, you need to drive that equation, how the speed is varying with time, or if you are having your speed.
Oh, sir. Oh, sir. Okay, sir. Thank you.
Thank you.
Yes, sir. Please go ahead.
Sir, my name is R.S. Kiran. I'm talking from Sankirka Vidya Parishad Engineering College, Visakhapatnam.
Yes.
Sir, why can't we convert rail body into or carriage into composite material body like we have these Volvo buses and other buses, so that the weight could be reduced further and we can have more number of MMTS in and around the country, because that would reduce the cost of transportation as well.
Okay. So what is happening these days is that what you have suggested and what you are seeing, it is happening actually. The Elstrom is trying to develop a coach with carbon reinforced plastic material. So they are making the system very light, and they are reducing the weight by way too much. They have already developed the prototype, and the manufacturing of the prototype has been done. I have seen by myself itself, and they are now trying to doing the analysis to it, whether it is sustainable with different type of vibration, temperature, pressure kind of a thing. So they are trying to develop that system as well. What you are saying, yes, they are into it. They are working on it. Maybe within 5 years, 5 years, you can see much lighter coaches compared to what we are having these days.
So the transportation cost also will come down for the common man.
That depends because transportation cost does not only depend upon the car body structural analysis, it also depend upon the inflation, how the transportation from one part to another part is taking place, like how many operators are involved, how many tariffs they are giving. So just by reducing the weight, the cost will come down. I am not sure. Maybe the cost to the buyer will come down, but for the public fare system and those things, I think that needs to be depending upon various other factors also.
Yes, sir. Yes. Sir. Thank you, sir. Thank you.
Yeah.
Any other questions, please? Okay. Yeah. Maybe we can.
Sir, Satyanarayan Garu raised hand.
Okay, so just one question, sir. Actually, there are about 5 steps are there actually in the entire digital twinning. So that means the first probably after gathering the data, processing data, and combined with the machine learning.
Yeah.
So that you said it's in one of the previous last slides you mentioned.
Yeah.
So by combining these after gathering data, processing data with the machine learning, is it going to, going to be more efficient, going to solve much more problems, and efficiency is going to increase? I mean, time of prediction is going to decrease is my question, sir.
What I've understood that you are asking if we implement the machine learning to understand the data and the predictions coming from the machine learning will help us to reduce the downtime or help us in the maintenance and those kind of a thing. Is that right?
Yes, sir. Yes.
Yeah. Yes, definitely. It is already in place. Many sector, for an example, if you take the aviation sector, you take the railway systems, you take the many industries with large pumps, boilers, and other things are there. They are already implemented the digital twins. They are using the machine learning technique to do the entire optimization. You can say the optimization. In fact, once they will having lot of things, they will do this confidence. You can say the confusion matrix kind of a thing to rank about how the data can get ranked, which are the playing major role, which are not playing the major role. So by that elimination process, the machine learning is continuously developing it, and they are of course reducing lot of maintenance time and as well as increasing the life of the product also.
Okay. Thank you, sir. Thank you.
Yeah. Thank you.
Yeah. Thank you. Like. Probably we'll close this session here. Suman, session coordinator, are you ready with?
Yes, sir. Yes, sir. Yes.
Yeah, sir. Session. Please summarize the session.
Yes, sir. Thank you, Dr. Sunil Kumar Sharma, for an insightful and engaging presentation on digital twins in railway systems. The section was highly informative, covering essential concepts such as definitions of digital twins and their numerous applications in railways. You explained how digital twins serve as a virtual representation of physical assets, continuously update with real-time data to create a dynamic, accurate digital replica. Your decision on applications on digital twins such as predictive maintenance, asset optimization, performance analysis, design and simulation of train was particularly valuable. We also appreciate the case study on railway dynamics, which helped clarify the complexities involved in the railway system, including the interaction between locomotives, bogies, suspension system, and track irregularities. The integration of digital twins in addressing these challenges and limitations that are three in a particular implementation and improving system stability was fascinating. Additionally, your insights into the future trends of digital twins in railway systems showed how they can drive innovations that enhance safety, efficiency, and comfort. Thank you for sharing your expertise and inspiring with us existing possibilities of technology transforming the railway industries. Thank you, sir.
Thank you so much. And I would also like to thank you, the organizer, for inviting me and for delivering me this session. Thank you so much.
Thank you, Professor Sunil. Yeah. Participants will break for 5 minutes. Now, we are the next resource person will be joining us in couple of minutes.
Sir, send me feedback. Not open link.
Yes, we have shared it, and I'm looking after the problem. Yes, I understood the problem. Some people are unable to
It will be
access it.
it will be corrected, sir. Yeah,
Yes.
you can join us in couple of minutes.
Shortly, it will be sorted out, sir.
Yeah, participants, be in the session, but you can take a break. Maybe you can take a breather for 4 or 5 minutes. The resource person is ready. He is about to start in couple of minutes.